This is a short introduction to what quadratic equation is all about. Well, quadratic equations are basically second order polynomial equations, okay, or polynomials with degree 2. Alright, it always comes in the form like this, okay, ax squared plus bx plus c equals to 0. So this is a quadratic equation when a is not 0. Alright, now examples of quadratic equation would be, for example, 2x squared plus 3x plus 5 equals to 0. This is a quadratic equation. Okay, another example would be x squared plus 2, okay, equals to 0. This is another quadratic equation. So as long as an equation involving x squared, okay, it is known as a quadratic equation. Okay, so what are you going to learn in this chapter? Well, firstly, you are going to learn how to identify the nature of roots of a quadratic equation. Next, you are going to learn how to find the maximum or minimum points of a quadratic equation by completing the square. Okay, you're going to find out how to sketch a quadratic equation the quickest time possible. Then you are going to learn how to find the range of values of an inequality by sketching graphs or by number lines. Next, you will learn to apply the relationship between the determinant and nature of a roots to solve problems involving intersection of a line and a curve. Lastly, you will be able to understand the conditions for quadratic equations to be always positive or always negative. At the end of the whole topic, you should have a very solid understanding of what quadratic equations are all about. Let us get started by talking about the nature of roots of a quadratic equation. Just what are roots of a quadratic equation? Well, roots are the factors of a quadratic equation, the x-intercept of a quadratic equation, as well as the solution to a quadratic equation. So all these terms are known as roots. So for a quadratic equation such as ax squared plus bx plus c equals to 0, you know that you can find its solution by using this general formula. Okay? So this is the general formula which later on in the chapter we'll try to prove. We will try to prove or rather derive how this general formula comes about. Okay? But what is more important now is what goes on in this general formula. Okay? Now all of us know that we cannot square root a negative number, isn't it? Now, what happens if your b squared minus 4ac happens to be a negative number? Well, because this number b squared minus 4ac is so important, it has a name. We call it the discriminant. Now, as you may know, your quadratic equation can look like this with respect to your x-axis. So the horizontal line here is your x-axis. Alright, you can choose to cut your x-axis at 2 points. Okay? Now likewise, it can be a quadratic equation that only touches the x-axis at only 1 point. Okay? Well, guess what? The quadratic equation can also choose not to cut the x-axis at all. Now, when your quadratic equation cuts the x-axis at 2 points, it means that there are two real roots. There are two roots, two real and distinct roots. That means to say there are two distinct values for x-intercept. Now, this happens when the discriminant is greater than 0. Now it makes perfect sense, isn't it? Think about it. If your b squared minus 4ac happens to be a positive number, say 4. Okay, so b squared minus 4ac is a positive number 4. Now your x according to the formula, your x will be negative b plus minus square root of 4 over 2a, isn't it? Now, this plus minus simply says that, well, your x can be negative b plus 2 over 2a or negative b minus 2 over 2a. How I get this plus 2 and minus 2 is from here, the square root of 4. Okay, because when you square root 4, you get a 2. Well, the root or the solution, your x values, okay, can take two different values here. Okay, it can have a plus value or a minus value, which geometrically interprets into two real intersection, two real roots, two factors, two solutions, whatever you call it. Okay, which is simply known as two real and distinct roots. Now, how about when your quadratic equation only intersects the x-axis at one point, which simply means that the x-axis is tangent to the quadratic equation? Now, this will happen when the discriminant is equal to 0. Okay, we call it repeated roots. Okay, now there are still two roots here. Okay, two, but they are of the same. Okay, so we call it two real and equal roots, or sometimes we call it coincident roots. Now again, it makes perfect sense, isn't it? When you have a square root of 0, what do you get? Well, square root 0, you get 0, isn't it? So when you have negative b plus a 0 or negative b minus a 0, do you think there is any effect to the negative b? Obviously not, right? And therefore, whether you plus or you minus, you have the same x values. But there are two x values actually, because there's plus and a minus. So the two real roots, but they are repeated roots, or they are known as equal roots. Okay, now lastly, what if your quadratic equation happens to be hovering above the x-axis like this? When it is hovering above the x-axis like this, is there any x-intercept? No, right? So if there is no x-intercept, it means that there is no factors, there is no solution, and there is no roots. And that happens when our discriminant b squared minus 4ac is less than 0. We call this complex roots or imaginary roots. Simply means that the roots don't exist. Now, again, how does it make sense? Well, think about it. We just mentioned, right, that we cannot square root a negative number. Right? You can always try it on the calculator and see what you get. Okay, when you key in your calculator with the square root of negative 1 or square root of negative 2, in fact, square root of any negative number, you get an error. You cannot square root a negative number. Okay, at least in our syllabus for now. Alright, so we cannot square root a negative number. It is no such number. Alright, there is no such number, and therefore there is no such solution. So there's no such value for x, and therefore there is no real roots for x. These are complex roots for x. Okay, so now in short, a quadratic equation can only have three different cases. The first case, it can have two intersections. We call it two real and distinct roots. Alright, it can also have one real root, okay, one intersection, but this is actually two real roots, okay, but we call them equal roots. Likewise, you can choose not to intersect the x-axis at all, and therefore there's no real roots, no x-intercept. So this is, in summary, what the nature of roots of a quadratic equation is all about.